In my arsenal of various capacitor testers in my lab, I have one of these Peak Atlas model ESR70 ESR testers. This is hardly the most sophisticated tester I have, but it's one of the handiest. And it's become my go-to just because it's so quick and easy to use. It has a downside in that it does not test DCR, and I'll forgive it that shortcoming just because it's so handy for many applications. Now I have the gold version. There's the regular ESR70, there's the ESR70 Plus, there's the ESR70 Gold. This is the Gold. This should be the most recent version. It tests the ESR of a capacitor. It also is a good checker for low resistances, anything below 40 ohms, down to 2 fractional decimal points. For example, down to 0.01 ohms. So it can be used that way, sometimes better than a typical inexpensive digital multimeter can test. And it also tests the capacitance. Now as it comes, it has a pair of small alligator clips on it, and they have these quick disconnects on them. So you end up with these two male prongs after you've removed the alligator clips, and these are 2mm sized banana plugs. They're about half the size of normal banana plugs, and they're becoming common for applications like this. I really don't see these being used anywhere else than for test leads, but I imagine they are somewhere. I also don't see many manufacturers making these, although there's a fair number of oddball Chinese ones that you can find on eBay and other places. But from mainstream recognizable manufacturers, I don't see them very much. And they're not always called 2mm size. They're often called minis or micros or all sorts of odd terminologies. I'm going to stick with the 2mm size. If you want to connect these banana plugs to something besides the included alligator clips, you have a few options. One way is you can go online from a number of suppliers. I actually bought these from Amazon. You can buy a little bag of 2mm male and female connectors, gold plated. One is the female. It's just that's a solder cup on the end, so you can melt a little solder in there and stick the stripped end of a wire in. And the other end is tubular, and it has a hole in the side, which I'm not absolutely positive, but I think that may be just to allow air to be displaced when you're plugging in something. I'm not sure. It doesn't seem to have anything to do with the solder cup on the end. So I'm going with the air displacement theory. And then the male part also has a solder cup on one end, and then of course the springy banana plug type shape that we're used to here. And they plug together pretty as you please. And then unplug. So using these, you can get yourself a bag of these for just a few dollars and make up as many types of connectors as you want to go from things like this to things like this, or to make similar disconnects for various other types of test leads and other applications as well. Anywhere where you want a good solid connector that'll stay together until you unplug it and has very good physical fit and an excellent electrical connectivity. Except for this application, I decided not to use them because then I'd have to put shrink tube over them or something. And I recognize that in some of the documentation, Peak says that you can buy test probes that go with this, but I couldn't find anything very specific on it, nor did I find anybody selling such test probes. So I did a little bit of digging, and literally the only test probes I could find that accepted a 2mm banana plug on the rear end were these that are made by Pomona Electronics, which is of course a venerable and well-respected high-quality maker of test leads and other things of that sort. I found very few places that sell these, or at least have stock on them. I bought these from DigiKey. They did have stock, although it was, I think, like 13 pieces in stock. And I'm not sure if they're still being produced or if this is just something they still had and maybe you can't actually get them anymore. I don't have that information, but it did seem like there was a shortage of supply. Nevertheless, I'm pointing this out now in case it can help somebody else. Now these are pretty deluxe, high quality probes. They, besides having the 2mm female jack on the rear end to connect up test leads, they have what they're considered to be surface mount device probes, so very small, micro-sized probes, not your usual big ones like you'd find on your typical, digital multimeter test probes. These are, maybe a quarter that size or a third that size. Little needle points, steel, not brass or something, so they're very robust. They're not likely to get snapped off. They're also spring-loaded. And they have a nice, solid, heavy, high-quality feel to them. But they aren't cheap, as I said before. They're getting their money for these. Of course, most Pomona things are that way. They're not a discount brand. They're a premium brand. Now, besides the spring-loaded part, they also come with these little caps which snap on, and if you push them on all the way, the spring tip just barely protrudes on the end through a hole in the end of the cap. So it's still there, but most of it's shielded, or not shielded but shrouded. But you can still use it to make connection. You can also put them on where they're not quite pushed in all the way, in which case you don't make any connection at the end. Then you can snap them on the rest of the way, and then the tip is exposed. When you pull these off, it's real easy to jab yourself because they come off and then you kind of tend to rebound. But the good thing is, because the spring tips are spring loaded, it's not going to poke you very deeply. It'll hurt though. It'll give you a good jab, but it won't go in very far because of the spring-loaded action. So when you've got them plugged into the ESR70's test leads, this is what you've got. Very nice. So this video wasn't really meant to be about the ESR70 itself, just the enhancement of adding the different type of lead. And oh, by the way, I did find another application for these. I can get the glomper clips, which are just the little hook type spring loaded clips that Pomona is famous for and have been ripped off and made by lots of other companies. And if you have a set of those, you can cut one of them in half, so you're cutting a glomper clip to glomper clip lead in half, and then stripping and soldering the ends of those two wires and soldering them into a pair of these, then you've got a way to connect those to these test leads instead of the alligator clips, instead of the test probes. I'll probably be doing that with mine. The only other thing I'm going to say about this, it's not really about the probes, it's just something I came up with myself as a memory refresher. I went through the manual and jotted down, I think, the most important points from the manual and put them on this little 1 inch by 3 1/4 inch piece of, well, it isn't paper, it's the laser printable plastic, which you can use instead of paper. But I stuck it on here with permanent adhesive, and it just has a list of those things that I might want to use as a memory jog. Polarity is not important because it's using an AC signal. It wouldn't be if it was able to measure DCR, but since it's ESR only, it's only putting out an AC signal, and therefore it doesn't matter which way you put the probes on a polarized capacitor like an aluminum electrolytic. Pre-discharge not required unless prompted. As it says in the manual, this automatically discharges caps before testing them, but if it detects that the voltage is too high, it won't attempt to do that because its internal discharge resistor would probably get burned out. In that case, it just does not proceed with the test and puts a message on there that you need to discharge it before it'll continue. So this is a reminder of that. Reminds me that the test frequency is 100 kilohertz, that it ignores capacitive reactance in the capacitor, only looks at the ESR. The analysis starts when the capacitor is connected or when the on test button is pushed. There's some people on YouTube who've made videos about how it was easy to connect up using the other hole in the case, a lead going to a little foot pedal or some other kind of switch, so if both hands are busy with probes or something, then you could still trigger a new test. Of course, simply disconnecting one of the probes from a capacitor and then reconnecting the probe or the clip, it would start a new test anyway. But they may have older versions of this product that maybe did not do that. This one certainly checks to see if something is connected, and if something is reconnected, then it automatically starts an analysis procedure. If an invalid test, it reads in circuit / leaky. The test current is 2 milliamps unless an asterisk appears on the display, then you can assume it's 20 milliamps. The sounds are a short blip at the start and the end of analysis, or a high to low beep barp. That means the ESR is greater than 40 ohms, which is considered unacceptable for any type of capacitor. Just a short ping means it's less than 1 ohm. Well, that's a typo. I can't believe I missed that. It should be 5 ohms. And then a ping ping if it's less than 1 ohm. Well, you look at these things over and over, proofreading, and you still miss something. Very frustrating. And then the ESR range that this can measure is 0 to 40 ohms. So that might be of use to somebody. Well, I decided to make up a set of these glomper clip ends for the test leads and include them in this video. So I just cut these off of an original clip-to-clip pair. I cut about a foot out of the middle, left only 2 or 3 inches at each end, and soldered on the barrels, the 2mm banana barrels. And now that should plug in nicely. Yep, went in very nicely. Of course, anytime you change the leads, and probably before every testing session, you should re-zero or compensate the tester to its probes. So I turn it on. I hold the on test button for 4 seconds. It'll say sound and probe options, and you can select yes or no for sound. I go with sound, so I push the on button, which is equal to yes. And then it says, do you want to compensate the probes, yes or no? And I say yes, or on for yes. And it says short probes and press test. So I have them clipped together, and I push test. It acknowledges that I did it, and it verifies that I'm in an in-circuit short situation with an ESR of 0.00 ohms. So the probes have been compensated now. I think it just stays there until I do something else, so I'm going to tell it that I'm doing a new test. And it says, hey, the probes are not connected to anything. It's an open circuit. So I clip them back together, and it says, okay, we've got an in-circuit short situation, ESR of 0.00 ohms. And I've got this brand new capacitor, which I'm going to clip on. It says analyzing 230 microfarads. It's supposed to be 250 and 0.09 ohms ESR. So this is a 250 microfarad cap. Closest is 220 on the chart, and it's a 25 volt part. So the ESR should be no more than 0.84 ohms, and it's 0.09. So very good in terms of ESR for that capacitor. And the tolerance on this part isn't great. I don't know if it says on here what it is, but it's probably only like 10%, or maybe not even that good, might be 20%. That's not uncommon for aluminum electrolytic capacitors. I've got this other capacitor, 470 at 50. It's a nice new Nichicon part. 456 microfarads, certainly within tolerance. 0.06. The chart says for a 470 ohm part at 50 volts, it should be 0.28 ohms or less. That's 0.06. So again, a good capacitor in terms of ESR.